Bismillahirrahmanirrahim. Assalamu alaikum, dear students. We are studying the course Quantum Mechanics 2. This is lecture number 2 for class BS6 semester and MSc part 2. I am your instructor, Jamshed Khan. Today, the topic which we are going to study is time-independent perturbation theory. As you remember, in the previous lecture, I divided this time-independent perturbation theory into the two parts. One is non-degenerate perturbation theory and the other one is degenerate perturbation theory. In this lecture, we study about the non-degenerate perturbation theory. Perturbation theory is suitable for the problems where the difference between the two problems is very small. Hamiltonian of a system can be written as h hat is equal to h naught hat plus hp hat. Here, the h naught is the unperturbed Hamiltonian, whereas hp hat is the perturbed Hamiltonian. For the sake of convenience, in hp instead of h naught hat and hp hat. Here, the difference between the h and h naught is very small, and the hp is small as compared to h naught. Both are time independent. Let us start from the unperturbed state. As I have earlier mentioned that in this lecture we deal with the non-degenerate perturbation theory. So, the unperturbed state of a system is represented by psi n naught, and the unperturbed Hamiltonian is represented by h naught, and the energy by E n naught. Time-independent Schrödinger wave equation for some potential, say one-dimensional infinite sphere well, can be written as h naught psi n naught is equal to E n naught psi n naught. Complete set of orthonormal eigenfunctions of psi n naught can be written as psi n naught and psi n naught. This is known as the inner product of the eigenfunction is equal to delta nm. This delta nm is equal to 1 for m is equal to n, and this delta is equal to 0 if m not equal to n. Now, we perturb the system by some means as shown in the figure. We perturb the infinite potential well by putting a little bump in the bottom of the well. So, the time-independent Schrödinger wave equation can be written as h psi n is equal to E n psi n. For the perturbed state, Hamiltonian of a system can be written as a combination of unperturbed and the perturbed part. Here, h naught plus lambda times hp. Here I introduced a dimensionless Lear parameter which describes the strength of perturbation. Here lambda is very less than 1. As we are discussing about the non-degenerate perturbation theory, so psi n and En as the power series in lambda. Psi n is equal to psi n naught plus lambda 1 psi n 1 plus lambda 2 psi n 2. Here lambda naught is equal to 1 and En is equal to En naught plus lambda 1 En 1 and lambda 2 En 2 plus up to so on. Equation number 4 and 5 are known as the linear combination of psi and n. In this equation, lambda 1 psi n 1 and lambda 1 En 1 are known as first order fraction of wave function and the energy. And lambda 2 and psi n2 and lambda 2 T n2 are known as second order correction. Using equation 3, 4 and 5 in equation 2, this equation 2 modify as h0 plus lambda hp. This bracket is for psi n, this bracket for en, and this bracket stands for psi n. Comparing the coefficient of lambda naught, lambda 1 and lambda 2 in equation number 6, after performing some mathematical calculation, we got these three equations: equation number 7, 8 and 9. Equation number 7 represents the coefficient of lambda naught, and equation number 8 represents the coefficient of lambda 1, and equation number 9 represents the coefficient of lambda 2. First order correction to the energy and wave function. We focus ourselves to the equation number 8, because equation number 7 is known as the unperturbed Schrödinger wave equation for infinite square value. And this equation number 8 can be solved for finding the first order correction in wave function and energy. Take the inner product with psi n naught of this equation number 8. Psi n naught h naught psi n1 plus psi n naught hp and psi n naught. On the right hand side, T n naught and the product of psi n naught and psi n1 plus T n1 and the product of psi n naught and psi n naught. The left hand side of this equation, the first term over here, we apply the condition of Hermitian, as h0 is the Hermitian operator. So we can write this h0 on the left hand side of this eigenfunction. So h0 and psi n naught. As we know that operator operates on a wave function will regenerate with an energy eigenvalue En. So this En can be written outside the bracket En naught, and remaining product can be written as psi n naught and psi n1. In the above equation, we use psi n naught and psi n naught is equal to 1, as can be seen on the right hand side, and the second term on the left. So using this part, En1 can be calculated as En1 is equal to psi n naught hp and psi n naught, because the first term on the left hand side is now cancelled by the term on the right hand side of this equation. So the two terms remaining, the second term on the right hand side and the second term on the left hand side. This equation is known as first order correction in energy. First order correction to the energy is the expectation value of the perturbation in the unperturbed state. Now we calculate the first order correction to the wave function. We can rewrite equation number 8 in this form: h0 minus En naught is psi n1 is equal to minus hp minus En1 and psi n naught. Psi n1 can be expressed as the linear combination such as psi n1 is equal to summation m not equal to n c mn and psi m naught. Here we introduced another unperturbed wave function psi m naught. This Cm is the coefficient of the linear combination of the wave function. By using equation number 13 and equation number 45 in this form. After performing some mathematical calculation and rearranging the terms, we will see the above equation as summation m not equal to n E m naught minus E m naught C m n and psi m naught is equal to minus HP minus E m1 and psi m. Here we take the inner product with another unperturbed wave function psi l naught. In order to simplify, we take this inner product for L is equal to n, the left hand side is 0 because psi m naught and psi m naught is equal to 0 for m not equal to n. For L not equal to n, summation all over the term over m is 0 except for L is equal to n. So the equation number 50 E L naught minus E n naught C ln is equal to minus psi l naught HP psi m naught plus E1 into 0. Now we are in the condition to find out the value of C ln by dividing the left hand side E L naught minus E L naught on the right hand side of the equation and replacing L with that, we get this equation number 17. Cmn is equal to psi m naught HP and psi m naught divided by En naught minus En naught. Now use the value of Cmn in equation number 13. We will get psi m1 in the form summation m not equal to n. This is the value of Cmn and this is the unperturbed eigenfunction psi m naught. This equation is known as the first order correction to the wave function. Similarly, we can find out the second order correction in energy by taking the inner product of equation number 9 with psi m naught. Equation number 9 will modify in this form as written on this paper. Now again apply the condition of hermiticity on the first term on the left hand side. In the similar pattern, H naught can be taken on the left hand side and this operator apply on the wave function. Pm comes out of the bracket naught and psi n naught and psi n 2. Here in the above equation number 18, the right hand side, the second term on the right hand side, psi n naught and psi n1 goes to 0 and psi n naught and psi n naught goes to 1. So after simplification, En2 is written as psi n naught HP and psi n1. Put the value of psi n1 from the above equation. This equation Es summation m not equal to n psi m naught HP psi m naught mod square divided by En naught minus En naught. Thank you.